We welcome everyone for joining us, and we would love to have more students joining us today to get advantage of today's meeting. So maybe Kantoush Sensei, we can start slowly while more students can join us. Thank you very much, Sensei.
Thank you very much, Dr. Khawla and all J-MENA office for organizing this seminar. Welcome everyone. So my name is Sameh Kantoush. I'm working as associate professor at Kyoto University in Japan. And my major is river engineering and dam engineering. So while we are waiting for other more groups to join, so I would like to introduce some of these pictures which I already shown here. So the first movie here, you can see a release from a dam during flood. And it's, as you can see, there are several gates or spillway gates from the dam are open to release the flood, and this is the reservoir in the upstream here. I will try to show maybe later on, but maybe in the upper part of the image is the reservoir, and the downstream part is the release from the dam itself. And this is one of the most important dams in Cagayan River Basin in the Philippines, and it's one of the recent basin faced with flooding in the northern part of Philippines. And this picture shows the river basin example, or even we can call it as a wadi also basin. So the river basin contains of several small streams and a combined or various dams have been constructed along these streams and going in the another reach and until the seaside or coastal area. And the last picture showing the reservoir, which is here, and just before the dam, here's the dam, this is the reservoir, and the water are coming from the upstream, going to the downstream in the river or the wadi. And once we have a reservoir or constructing a dam, then many issues related to reservoir sedimentation. Reservoir sedimentation means all coming sediment from the upstream will be deposited in front of the dam itself. And how to manage this sediment in the reservoir or in the upstream reach. This is today's topic. We are calling integrated, means a comprehensive strategy from the mountain, from the catchment until the seaside for flood and the sediment. Okay. If you have any question, please write in the chat box, or even you can talk, and Dr. Khawla and the group from J-MENA office will give you the floor to talk. I'm not sure about your backgrounds, all of you today are attending. So please feel free to ask any technical questions which is really far from your background, or even if you are a specialist, please talk more. Okay, so there are various challenges facing the basins or many countries. So for instance, in Japan, frequent heavy rainfall and severe typhoon means cyclones, attached to the western part in 2018. In 2019 also, very strong typhoon Hagibis delivered a huge rainfall. Many embankment of the river, we call it levee breach, and inundation means flooding exists in the area where, or water exists in the area where it should not be, and emergency spillway gate operation, which you saw in the first movie. 2020 also severe rainfall with the severe flooding in Koma River and Kyushu area where J-MENA is located in Kyushu University, and several other typhoon also 2021 have been occurred. So in other countries, let's say like in Vietnam, also in Asia, successive typhoons, successive means continuous, several typhoons have been hitting the central part of Vietnam with a very long lasting heavy rainfall from 6th of October until 1st of December. We call many different, every typhoon has a different name. Like Lympha brought more rainfall with more than 800 millimeter per day, with a total 3,300 millimeter during this period of 15 days, and large-scale flood with a heavy damages. Also in the Philippines, 5 successive tropical cyclones before Ulysses lashed the main island of Luzon Island in November 2020, which triggered lots of flooding affecting 8 regions. And in the Middle East and the North Africa, many countries in 2020 have been hit or flooded. Into 2021, if you remember, the cyclone Shaheen in Oman created lots of damages and inundation area in Oman, and the heavy losses as well. Algeria in 2021 as well. So under these circumstances, in order to make our society more resilient, social adaptation to the hazard and the countermeasure for disasters, it is required based on technologies for assessment, prediction of the future condition of the water resources and disaster risk reduction. So I am showing now some pictures related to the real inundation in after Typhoon Hagibis in Japan, in the Tohoku area or other area. So you can see the real inundation due to the breaching of the embankment, and many areas, even Shinkansen area, have been flooded in this typhoon. And this is the hazard map even before. This is another example in Koma River, where the 24 hours cumulative rainfall on the left picture here, you can see this is Hitoshi city, and the flooding nearby the Koma River is really very severely damaged many areas. I have to say that most of the flooding issue is really can be combined with another secondary disaster. For instance, the disaster related to the COVID-19 as well. So many hospitals. Someone has a question? Okay. So, yes. So many areas or buildings like hospitals have people who are treated due to the COVID, but at the same time, these hospitals are critical buildings due to the flooding issue. You can see this, another example, these lines are the cyclone tracks. that crossed the Philippines between 2011 and 2021. This part in the north, we call Lawson Island. I don't know, you can see my screen mouse are moving. So the Lawson Island have been hit with 5 successive typhoons, which caused more than 70 deaths and 85 injured, with more than 400,000 US$ as damage cost. And as you can see in this picture on the right side, this is the Cagayan River Basin. And here are the flooding picture in Cagayan River and Bonton Bridge on the right side, flood inundation in Elegant City, and agriculture area have been flooded. This picture here in the middle, this is showing the spatial distribution of the rainfall. You can see very high near the mountain and the very much unhomogeneous rainfall distribution in the east and west part and north and south. This example from the flood and the sediment disaster in 2020 for Typhoon Lympha in northern part. This is the map of Vietnam. I don't know, you can see my mouse again or not, but
we can see the most clearly. Thank you.
Okay, very good. So thank you, Dr. Khawla. So you can see this is the map of Vietnam, and this is the central part where we have a very interesting basin we call Vuja Two-Bone River Basin. This basin is really very unique because it's too much hit by typhoon, and at the same time, this black point is a kind of dams or hydropower dams. And this red color is a kind of hydrological station for rainfall, flow discharge, and the meteorological stations for rainfall as well. Here is hydrological for water level, sorry, and the discharge, but green is for rainfall. So there are many activities in this basin, as I said, because of sand mining. Many ships are taking sand for construction and for selling this sand as a material. And last typhoon caused a very heavy damage of flooding with a 3-meter water depth in many big areas. And as you can see, some problems due to the riverbank erosion and flooding as well. If we go to your area, flash flood or Middle East and the North African MENA region are not so far also from the extreme flash floods. So many frequent flooding for many different areas with high loss of life and high loss economic damages, as you can see in Morocco, in Tunisia, in Libya, in Algeria, in Sudan, Egypt, and many other parts, Iran, Saudi Arabia, also maybe later on in UAE or Yemen, Oman. So many flooding occurred with many damages and the loss of life. It's really very severely hitting almost since 20 years, very high frequently and very high intensity of rainfall and flooding and disaster due to these different floods. And at the same time, the Middle East and North Africa are hit by also cyclones. So here I am showing several cyclones and occurred in Oman, especially in Oman. This is the last cyclone, like Shaheen cyclone, with a very high rainfall, more than 369 millimeter, and a very high number of loss of life. previously also many cyclones like Gono with more than 4 billion US dollar as a damage cost, and Fit in 2010, and many other areas. But Cyclone Shaheen, the most important part is high flow and the sediment. And you can see some of these pictures of flooding, inundation, and damaging due to the sediment movement. This black dot here are the location of the dams in the Oman, where it is concentrated in the northern part, where high rainfall and also large number of cyclones are hitting this area. Sorry, this is the one important problem in the archaeological wadi. This is Petra. This is the Jordan, and here you have the Petra, which is very beautiful archaeological park, where it is a UNESCO World Heritage Site, and frequently this site have been hit also by flash flood. So many tourists, more than 4,000 tourists, were on risk at sightseeing flood-prone archaeological area on November 2018. And as you can see, all of this water are going to from the Wadi Musa, which is the upstream part in this, which is going to the Sikh area of Al-Bitra. So as I said, flash flood is really a big damage, and combined with sediment disaster, causing lots of severe human and economic loss. So to summarize all of this, this common challenge along river basin, starting from the mountain area, where high rainfall generating high sediment inflow, and the water with the sediment will come along the river. And sometimes in the upstream area, we have lots of flood risk, and also in the downstream area as well, with flooding and bank erosion. Therefore, we have many dams constructed to protect the downstream area from this high flow and sediment. But this kind of anthropogenic or human intervention will cause another problem, and causing a reservoir sedimentation. And in order to manage the flow and the sediment from the catchment until the sea, we have to make lots of, or construct several options to divert flow and sediment and reduce the environmental problem due to such dam construction. So in the downstream area, we have lots of issues related to the river ecosystem damages, a river morphologically change, and bank erosion, and as well as salinity intrusion in the delta area, and causing lots of coastal erosion. So downstream river ecosystem will be affected by the dam and the reservoir sedimentation, also our delta and the coastal area. So due to climate change, due to human intervention, sand mining, dams, water allocation, all of this will be like large number of drivers affecting on the management of the river basin. As I said, if you go to the Wadi system, Wadi means, if someone are not familiar with the terminology of Wadi, Wadi is a dry river, is a completely a river, but without water and only functioning during a heavy rainfall, will be filled with water within 6 hours, okay? So in the Wadi also, we have a high runoff, high reach sediment coming and constructing dams, either for retention or either for recharging this water to the underground, because they would like to use this water for later on as a groundwater recharge and use it for agriculture issue. But these recharge dams sometimes causing lots of clogging for infiltration in the under the soil. Clogging means very fine sediment will enter between large particles, and then the soil will be like sealed or dammed. Nothing will go through the soil due to such clogging. So all of this will affect on the like coastal area, and also affecting on the water harvesting or gathering the water for agricultural uses. We have many sediment management options like dry excavation or other options, but as I mentioned, important drivers are climate change impacts, flood, and sediment management. And all of this should be also linked with the urban expansion, because many people are constructing their houses in the way where the flooding exists. Okay, do you have any questions until now or comments? Is there any comments in the chat box, Dr. Hawla, because I cannot see?
So far, I think we do not have any question or comments, but I think like the presentation is very interesting, so we wait to the end of the presentation. Yeah, thank you.
Okay. Thank you very much. Okay, so as I explained, the major impacts by a reservoir sedimentation, which is one part of the system in the river basin, you have the flow and sediment coming, causing a delta in front of the dam. And this is very fine sediment. This is medium size sediment, and this is coarse sediment. And there are many issues. Important issue in our river basin is the dam safety or the safety of the system itself, and how to create a reservoir sustainability and the reduction, because this sediment or reservoir sedimentation will reduce, as you can see, this is the original water level, high water level. But when you have too much sediment here, it will take 10%, 20%, 30%, or even more than 80% of the volume available for flooding and management will be filled with sediment. How to manage that? What we should do, and what are the management techniques to reduce the reservoir sedimentation and solve the problem which we call loss of functionality for the reservoir. Because in the presence of climate change, in the presence of natural disaster, this reservoir sedimentation will be increased and flooding also will be increased. How to recover? Because the dam itself is very important for flooding, for water supply, for many, many purposes. So in Japan, we have many options. We are working on that, many research in my group we are doing. So we have three options: either to reduce the sediment in the mountain coming inflow or generated sediment due to the rainfall, or we call sediment routing. Sediment routing means not allow the sediment to enter the reservoir, just route it, make a route through different options. And the third one, if the sediment is moving and settled in the reservoir itself, then how to remove sediment removal. So these three groups we classified here, and we summarize the common techniques or technology. I will not be able to talk about everything, but I will pick up some of these examples like sediment bypass tunnel or sediment flushing or other options to talk about it. So this map is very interesting, showing all dams in Japan, more than 900 dams. I mean, in Japan, we have more than 3,000 dams, but this map showing more than 900 dams where sediment management options have been implemented. So we have several techniques we call sediment flushing, or red color we call sediment sluicing, orange one, which we call sediment bypass tunnel, and sediment replenishment, blue one, and the others are no measures. So this map shows how our system are really unsustainable. You can see here, this is the sediment flushing. This is the dam itself, huh? And usually the water is very high. Reservoir is filled with water, but the concept of flushing, we have to open the gate, two gates on the right and left, to release the water and the sediment and create a high free flow flushing. And you can see in these results here, we could measure the water level. These are the important river basin we call Krobe River, very beautiful river. And in Toyama Prefecture, in this location here. And there are successive dams exist. So what we are doing is that the Shidaira Dam in the last and the Unazuki, before going to the coastal or to the sea, we are trying to reduce or open the gate and of the Shidaira and the draw down. Draw down means lowering the water level. And for 12 hours, we keep this condition as a free flow, and before recovering and filling again the reservoir. The other dam as well is creating the same, and we could measure the inflow discharge, outflow discharge, and water level. And at the same time, the important thing is to release high sediment, suspended sediment concentration, and to monitor this. This is the picture where the dam is completely no water in the reservoir. And we could measure many options. These are the original bed, and before and after the sediment or flushing, we are measuring the bathymetric survey or the bed level as well. And as well as we conducted numerical simulation to predict such a change. Sorry? Do you have questions, Saleh? Sorry, if you don't have question, please. Yes?
Just, excuse me, just let me ask my question in question and answer section if it's possible, or
at the end. So please mute yourself if possible.
Okay, sorry, thank you.
Okay. So this is the part related to the reservoir sedimentation. And as you can see, this is the coastal line change. And since 1947 until 2010, where the coastal area are very much recovered, as you can see in this picture, gradually recovering after 2000. This is another example from Mimi River in Kyushu in Miyazaki Prefecture. And there are 7 dams where the Ministry of Land and Infrastructure and Tourism had a new policy in order to upgrade the dam functionality. What are these new policy? They are starting to removing the existing two central parts of the spillway gates and constructing or installing a single spillway for increasing the release of flow and the sediment sluicing from the reservoir. This is the picture after the upgrading in Yamasobaro Dam, cutting and installing a new gate. And this is Saigo Dam, where two new spillway gates have been completed. This is another example where we have, we call sediment bypass. So flow, and this is the check dams, diversion weir, this is the main dam. And they have a bypass tunnel like this, very long, sometimes more than 2.5 kilometers. And during the flood, they start to open the gate and divert flow and the sediment. And after that, they stop again to refill the reservoir. So there are several types of sediment bypass tunnel, like Miwa Dam. It's only turbidity or suspended sediment will be diverted. Or here's Asahi bypass tunnel. It's diverting everything, as you can see in this picture. There are big boulders, and this movie showing only suspended sediment in Miwa Dam. So we tried to do many research to monitor the flow and the flow velocity on the Miwa Dam and the Miwa Reservoir in the upstream part and inside the tunnel, where we could see by using image technique the flow pattern and velocity diversion, and also detecting the suspended sediment concentration in the reservoir by different type of management. So the issue is how to, when we have to open, and how much the efficiency of this reservoir to recover the or diverting most of the sediment coming from the upstream. And the downstream morphological change, there are very good recovery. You can see this picture before bypass operation and after bypass operation, and the new gravel bar has been created just downstream of the dam, and due to the sluicing operation or the sediment bypass operation. Of course, this kind of river ecosystem also have been improved, and the change in the invertebrate community, because some of the species exist in the reservoir. The dam stopping moving such species, so we cannot see in the downstream area. But with this sediment bypass tunnel and the sluicing, some benthic invertebrate downstream become more like upstream within 2-3 years since the SBT operation have been started. Okay, so last part of my presentation, I would like to show some research related to the integrated flood and sediment management in the river basin for our running projects in Philippines and Vietnam. We have like 4 groups from the 3 institutions or 3 countries, Japan, Philippines, and Vietnam, related to climate change and the impacts and agriculture management, related to watershed and the reservoir sedimentation management, geomorphological change and the coastal erosion management, river basin policy and the decision management for sustainable development, and finally we have an integrated flood and sediment management group. So the main objective of this is to assess the climate change, climate variability, and its impacts on the rainfall runoff and sediment yield in both rivers in 2 countries, Vuja, Tu Bon in the central part of Vietnam, and the Cagayan River Basin in the Philippines. And we want to quantify the consequences of a changing climate on floods, droughts, agricultural activities, and river and the coastal erosion. Then we want to propose a countermeasure or suitable countermeasure for these problems. So to evaluate reservoir sedimentation and propose suitable sediment management technique, which is very much related to the first part, which I discussed, and develop integrated flood and sediment management for sustainable development, and establish some NGO association that can bridge in implementing this technology. We started with the post-flood survey. So this is the Vuja Tubon River Basin in Vietnam, where very high number of cyclones have been hitting this region. So this green marks is a kind of flood marks we collected from the real data. And we conducted this field survey to collect in collaboration with our group in Vietnam and Da Nang University. And at the same time, we tried to do or construct the same flood inundation map in the Cagayan River Basin. As you can see, downstream area have been flooding. In the inundation area is very huge in Cagayan River Basin in the Philippines as well. So we collected, based on our field investigation, two parts related to the flood marks and related to the inundation depth in the downstream reach where agriculture area or different land use have been flooding. So in Cagayan River Basin, in the Vuja Tubon in Philippines, this is the in the Vietnam, sorry, this is the Vietnam, and this is the our target basin, Vuja Tubon. Then we have different inventory map and influencing factors which are affecting on the flood inundation in this basin. So we tried to develop these maps and the factors, and from that we could use the machine learning techniques and hydrological modeling, rainfall runoff inundation model, in order to develop the flood susceptibility map. And it was very interesting to find a very good matching between the machine learning results and the hydrological based model results. So most of these downstream reach city have been flooded with a high risk of, or very high risk of flood inundation hazard map. We could use also different hydrological model and not only machine learning in order to understand the contribution of each river basin during flood. How much water or how much percentage will come, because this river basin had more than 18 dams. So we want to understand with and without dams, how much the contribution for the flow during heavy rainfall. In the Cagayan River Basin, there are only one large dam, which is called Magat Dam. And we tried to understand the contribution of each sub-basin as well. And we found that there are many sub-basins, which is this one we call Cagayan Segment 1. It's very high contribution of flow and also sediment. So it means that many subbasins are contributing a lot for the inundation in the downstream area. So we found also in the Vuja Tubon River Basin in Vietnam that very unique activities, human activities related to sand mining and causing lots of bank erosion and morphological change. Bank erosion means the bank of the river will be collapsed, and morphological change means some area will be narrow or widening due to the heavy deposition and erosion in the river course or river corridor. All of this red, yellow area is high sand mining location as well. And there are some linkage between sand mining and bank erosion location. So we have conducted several field surveys. This is one of the important things that we have to, because sometimes there is no available data, we have to create and collect our data by ourselves. So we conducted a bathymetric field survey in most of these cross sections, as you can see, along the river itself, in both rivers. This is Vuja and this is Tobon, and in between there is a one-way channel. We also collecting lots of samples for the sediment grain sizes, for the sediment concentration, to understand the soil type and to understand the composition of different formation of land use in order to easily simulate this river. We need to collect lots of data for calibrating our model. These are some of our results where collected bathymetry along the two rivers, Vuja and the Tobon River, and you can see that the riverbed is really getting in size, more narrow and deep with time. This is also due to many activities, due to sand mining, due to the dam impact. So here's also grain size distribution in one-way channel as well. If we go to the Cagayan River Basin in Philippines, again, we found that this is the main river from upstream to the downstream, and lots of more than 20 tributaries are bringing water and sediment to the main river. As I said, only Magat Dam as a one large dam, but many basins have been a large contribution to the flow and sediment. Magat Dam is, as you can see in this picture, also received lots of sedimentation in the reservoir, and more than 30% or 40% of the reservoir capacity have been lost. So a very high risk of losing the capacity of the reservoir. Therefore, we tried to do lots of scenarios and simulation for the option. Either we propose additional dam to support Magat Dam to reduce the flooding, or as you can see in this picture, this is the dam, very high water level, some water use capacity, and this is the sediment storage capacity. And this part between high and the normal is for flood control. So the important things is the dam operation itself, how to operate the dam. This is the reservoir water level, and this is the release discharge, red color, and this is the inflow. So if you have if you are lucky, we can do a dam pre-release, means open the gate and enlarge this part, more water storage available for flood, and then reduce the water use capacity. But in such a case, if there is no rainfall are coming and you have not good rainfall prediction, then you are not lucky to restore again the reservoir for usage in the agriculture in the next season or dry season. In such case, the dam pre-release is important and should be linked with high accuracy of rainfall prediction in order to not to lose the water for during droughts, or not to reduce or keep high water level, and then you receive too much water, then flooding will occur. So this big dilemma, therefore, we also conducted lots of post-flood survey and data collection in the Magat River Basin and downstream of Cagayan River Basin. Here's some results related to the hydrological response of each subbasin, and we could understand which subbasin is the champion contribution of the flow even during a normal rainfall pattern. And we could do simulation with and without dam, with additional dam supporting, and how to reduce the inundation in the downstream. These are the scenarios we have constructed. So finally, as a conclusion, the urban and agricultural region are the most prone area for flooding, as we saw. So many dams and sand mining, very high probability due to these human activities. So riverbed and morphological change, strong meandering inside the river section, wide and narrow, are a kind of bottleneck and increasing flooding and reducing based on this morphological change. Siltation management is important both for reservoir and river basin sustainability. Flushing, bypassing, sluicing, many attractive options for sediment management should be considered, and the dam retrofitting leads to reduce flood risk and improve river and ecosystem. So finally, there is an urgent need to optimize dam pre-release to balance between required storage for droughts and management strategy in reducing flood impact. And we have to consider a comprehensive sediment management, including the catchment or watershed sediment management and downstream and the coastal management as well. With this, I would like to thank you all for listening, and I am waiting for your questions. Thank you very much.
Thank you very much, Kantoush Sensei. That was a really very interesting presentation. Thank you very much again. So now we can start our question and answer section. We can start by the question of Mr. Salah. He already wrote his question. So he's saying, what's the role of soil conservation dams like gabion or concrete stone dams on the flood management in Wadi? What do you think, Kantoush Sensei?
Yeah, soil conservation means soil conservation dams, just like check dams, do you mean? So the main idea of these dams is to stop the sediment coming from the upstream in the Wadi, and also retain the flood and shock wave of the flood from the beginning. So this kind of gabion or concrete stone dam, like rock-filled dam, you mean? So this kind of dams, maybe it's a kind of very small, more than 5 meters or around 6 or 7 meters. Maximum is 10 meters. So these dams are very important for the flood management. But as I said, the age of these dams, with time, this will be filled with sediment. So how to manage? Because if the in front of the dam already filled with too much sediment from the Wadi, then these let's say check dams or retention dams or groundwater recharge dams are not valuable anymore. Okay, so it's very important, of course, but it should be considered how much coming sediment from the upstream, and then how much flow our water or rainfall runoff, and then you can easily design your dams, which you call gabion dam. And the important things is, if these dams someone would like to talk?
I think it's okay.
Yeah. So if these dams are able to, let's say, contain some bottom outlet, then that will be very good to manage and remove the flow and the sediment as well.
So
Okay.
I hope, yeah, thank you, Kantoush Sensei. I hope that's clear for Salah San. If anyone is having another question, do not hesitate to ask Kantoush Sensei. Do not miss the opportunity to learn more about water management, dams, etc.
Yeah, I can see many of my good friends, Clara and Professor Dochte also here. Many group also, Hadir. So thank you for joining. Yeah, please, Saleh.
Hello. Good evening, everybody. Thank you, Professor. I really enjoyed your presentation, and it was very interesting for me because I am a watershed management expert. But I have a question. Sorry, I didn't write it. Just to be clear for me, you know, in Middle East, the floods most of the time are opportunity for us. You know, most of the times the reservoir dams in Middle East are empty, are lower than the capacity, but the floods fill the dams, and the water is very important for us. So the sediment flushing is a good option. So that's why I asked about the gabions and check dams that you explain it very well, and the role of these kind of dams. But it is very important for me, how is the role of the vegetation recovery in watershed area before starting the sedimentation delivery to the river, along the river to the dams. Thank you so much, Professor.
Thank you very much. Yeah, so I agree with you that watershed management, in order to reduce the production. So the watershed is a kind of production. Please understand, the river or the wadi is a kind of belt conveyor. Belt conveyor means some part you generate or produce sediment, and your wadi will transport as a belt conveyor, and your coastal area or downstream reach will be receiving this sediment. Okay, so all system should be work or function together. In order to reduce in the upstream, you have to create lots of stabilization and terracing, many options with different indigenous technique also in Jordan, in Iran, in Oman. Many different countries, they have their original idea about this. But please consider always, when you construct a dam or any option in the wadi, how to create the flood and the sediment management together in order to keep the reservoir to live for a longer time. Okay. Thank you very much.
So thank you, Mr. Salah, for your interaction. We have another question also. So,
yes.
According to your experience, Kantoush Sensei, have dams been designed taking sediment transport into account? For example, in Jordan, this was often not the case. Many dams lost a lot of capacity. So is a redesign necessary?
Thank you very much for your question, Professor Dochte. Thank you very much. It's yes, I think this question is very important because we are familiar with many management options, but the question is, until now, not only in the Middle East, but even in many other countries in US or even in Europe, or now in Asia, they are constructing larger dams, and they are not considering the sediment transport or reservoir sedimentation. Some of them are doing, I should say that, but still large number of new projects are neglecting the equation or the issue of losing the reservoir because of the cost. If they consider now, they are thinking it's too expensive for them from the beginning. They should wait like 10 years or 5 years or 20 years, and then later they will make intervention. But they are not sure when this later will come. And due to the climate change, we can see that the reservoir filling with the sediment is very much accelerated in many areas. And in many cases, the losing of the trapping efficiency due to this sediment is very fast, very high. Okay. So you said that redesign. I think the redesign, the dam itself, it's a kind of, we are calling dam rehabilitation. Dam rehabilitation means either we install a new bottom outlet. This is the case we are doing a lot in Japan now. We are calling this like dam upgrading. And even you are talking about Jordan, there are, what they are doing in Jordan, they are doing dam heightening. Dam heightening means they are trying to construct or raising the dam body. So because the reservoir is losing capacity, so they raise the dam, then they try to gain more capacity. They are considering, but I think based on our research, this dam heightening sometimes it's less cost, of course, but sometimes is accelerating so much the reservoir sedimentation, as we saw in Morocco, a lot of cases. And sometimes the raising dam will cause a dam safety issue. Okay, so at the end, it's useless. You will increase the dam height, but you cannot recover the reservoir for the full storage because of the dam safety issue. Okay, so considering from the beginning, the sediment management option will reduce the cost, as we saw in many cases in Japan and worldwide. Thank you very much, Professor. Okay, Clara, thank you very much. Oh, so today's session is really very big experts are here.
We are really honored to have you all. Thank you very much.
Yeah.
Thank you very much.
They are my colleagues from German. We are collaborating in Jordan as well. I appreciate your attendance.
Highly.
Okay, so thanks a lot for your talk. With your experience, what is a good way to calculate the sediment load in wadis? Since after a flash flood, the wadi looks quite different. Okay. Clara, this is very difficult question. Yesterday, I just arrived from Oman. Because of that, I'm really very tired today. I still have time lag. We stayed in Oman almost 1 week. We want to just to answer your question, in fact. So what we tried to do, we installed several plate sensor. Plate sensor means we installed a microphone covered by steel plate. And this microphone is connected, microphone sensor is connected with a very high-tech circuits, and remotely we can access and check the frequency of hitting the stone or sediment. Of course, the minimum size should be around 2 millimeters. So hopefully this can be work as well, as we will install also the turbidity meter, because the question is how to calculate the sediment load. most of the available equations are not for the wadi. Okay, we cannot really answer this question easily. We try to do that by numerical simulation and the trial and error, because we have the bathymetry of the wadi in reservoir in Wadi Mijlas in Oman. And we tried by trial and error in the numerical simulation to increase the sediment load slowly until we reach the same bathymetry, but that was really not so good approach. But anyway, we reached to that. We have around 35 gram per liter are coming with one event. But another work with my student from Oman, we tried to do several analyses based on the morphological change in the mountainous area. So the wadi is very lucky because the bed is exposed. So we can see the bed before flood and we can see the bed after flood. This is really very unique. It's not the case in normal humid area rivers. So therefore we could analyze several events and we understood how much the sediment load are linked with the rainfall, and we developed some simple equation, but this is still very preliminary. We have to verify for different wadis and different areas in Oman and other areas as well, maybe in Morocco, Algeria. This is the case. So hopefully some of our students here today, Asma, inshallah, she will join us in the future. She can do or develop such equation as well for the wadi. Thank you very much.
Thank you very much, Kantoush Sensei, and thank you very much for the German team to join us today. We are very honored to have you all. And so I think we're getting close to the end of the session, but still, if you want to discuss more, you are very welcome.
Thank you. Thank you very much, Hadir. Thank you very much. Thank you, Mr. Saleh, and for all groups for your attending. It's really very, I surprised that some of you are attending. Thank you very much.
Many thanks.
Christina also, she's here. Thank you, Christina.
Thank you all. And we thank you again, Kantoush Sensei, for your time and cooperation. We know it's not easy after your trip, so we highly appreciate it. Thank you very much.
Okay, so Asma, she has a question. I have a question. What do you think, Sarah, about the accuracy of remote sensing data, open source data, where the area of dams is very small? You are right, Asma, that one of the trial we did with INSAR data. So remote sensing is INSAR. We found that the reservoir is really very small, but not only the reservoir, the wadi itself is very narrow. The INSAR is able to detect for a larger area within centimeter. Is still very good. I think if we can say that better than nothing. So we are trying now with different technique in order to implement or improve the INSAR treatment to narrow wadi or small wadi. So remote sensing is a good approach, and we should try and improve. Of course, accuracy will be a little bit less at the beginning, but if you can improve your treated parameter for the remote sensing data, that will be able to increase the accuracy as well. Thank you very much, Asma.